Well, hello, everybody, and welcome to today's session on the Untold Secrets to AI-based profit optimization, brought to you by CXO Sync UK in association with our sponsor and, of course, our lead contributor today, Pros. My name is Hamish Taylor, and it's my very great pleasure to be moderating today's session. Now, those of you that know me from previous sessions will know that I am certainly not an AI expert by any stretch of anybody's imagination. My career has been very much in line management. It took me from the wonderful world of household cleaning with Procter & Gamble as a brand manager through consultancy. I was head of brands at British Airways for a number of years. So if this was a lecture on putting beds in aeroplanes, I'd be your person. And then moved into chief executive roles, first of all with Eurostar, getting the French, the English and the Belgians to work together in perfect harmony, of course. And then I was chief executive of Sainsbury's Bank, the world's first supermarket bank. And for the last 20 years or so, I've been working around the world with organizations as an advisor and speaker, particularly on the whole area of sort of customer-led transformations. So that being the case with my background, why am I here and what are we going to discuss today? Well, I grew up in Procter & Gamble, as I mentioned. And Procter & Gamble prided themselves on being a data-driven organization back in the 1980s and 90s when I was there. And that suited me fine because I'm an econometrician by academic background. And in those days, I loved crunching the numbers. But in those days, all the numbers that you had on your business could be put on basically one Excel spreadsheet. Then along came the digital world and digital transformation. And for businesses, of course, that brings the potential for better communication and greater efficiency. But I think probably the biggest impact for me personally has been the exponential growth in the data that's available to us. Now, this extra data should, of course, be of tremendous benefit to organizations in determining their strategies and the tactics for their business. However, it only does that if they have the capability to gather this data and to turn it into insights and action. So on the one hand, you've got that going on. Let's look at the other side of things, profit optimization. That, of course, is the key goal for most businesses. So how can we use the growth of available data combined with new technology such as AI to get a step change in our ability to optimize our profit? Now, I'm, of course, far too old to be able to answer a question like that. But as a former CEO, I do quite like my profit. So fortunately, my guest today is someone who can show us the secret of unlocking the true potential of using AI to optimize our profit. And my guide through this today is a gentleman by the name of Michael Wu. Now, Michael is the chief AI strategist at Pros, a position he's held for the past 5 years. And prior to that, he had an academic career with the University of California, Berkeley, where he did a bachelor's in applied math, physics, and molecular cell biology. And he then went on to do a PhD in biophysics, specializing in computational visual neuroscience using statistical and machine learning techniques. He then, after that, started his career with 10 years with Lithium Technologies as a principal and then chief scientist. And in today's world with Pros, he describes himself as an AI scientist, neuroscientist, and behavior economist. Now, that makes him an interdisciplinary scientist, and he believes that gives him two missions in life. Number one, knowledge creation, doing good research to advance our understanding of the world and people around us, but also knowledge dissemination, educating people about this knowledge so people can actually use it to make the world a better place for themselves and for the people around them. So it's the knowledge dissemination piece that, of course, is going to bring us, he's going to bring us today. So let's bring Michael onto the stage, who is joining us from San Francisco. And Michael, I'm assuming that means you had to get out of your bed very early this morning to join us.
Indeed, it's about 7 a.m. here.
Oh dear, right. Well, we're in the middle of the afternoon over here in the UK, and as I said in our preamble, it's a blazing hot day here in Scotland. So I think for once we've got the advantage of you. We're slightly warmer than you here, the normal. Normally it's the other way around. Listen, Michael, thank you so much for joining us, and thank you, of course, to Pros for enabling this discussion. And I think just before we get into the topic at hand, I know we are going to talk a lot to our listeners today about AI. So I thought we might just start off with a little bit of making sure we all understand the terminology we're going to use. So first, let's kick off with what do you mean by AI when we say that?
Yeah, I think there are a lot of definitions for AI in the industry, but I think that the simplest way to understand it is just, it's a very simple definition that says AI is simply a machine mimicry of human behaviors with two very important characteristics. And one is the ability to automate human decisions and action. And then the other one is essentially the ability to learn. And what that means is that it has to be able to improve its performance with usage. Okay, the more you use it, the better it gets at what it's doing.
Now that's interesting, because I mean I get the bit about automating human decisions and acts. That's what most of us would understand and realize. But this business about learning. So how does AI actually learn then as it goes forward?
Yeah, so the tool that actually makes AI have the ability to learn is what we call machine learning. Okay? It's called machine learning for a reason, because it makes the machine.
Good title.
Yeah, and machine learning is, I think, the simplest way you could look at it is simply a process of turning data into a model, okay, into some kind of an algorithm. And that's actually what enables AI to learn from data, right? Because machine learning is a process that turns data into the model, and then the AI can actually use that model. Yeah.
So could you give me an example just to make sure I've got the story?
Yeah, I think certainly the most common, probably not the most common, but I would say like one of the most popular machine learning algorithm that's used today is neural network, right? And that actually powers everything from ChatGPT, to lots of, I would say, tools that we use on our phone, on the web and beyond. Okay. So neural network is basically a type of machine learning model that's actually inspired by the human brain, and it's made up of interconnecting nodes, just like the brain is made out of interconnecting neurons. And these neurons are typically arranged in layers, and you can actually adjust the connection weights between those layers to make each layer perform different functions. So that's how it's able to essentially learn and model the pattern in the data.
Right. So acting sort of like a brain almost on the way through. Okay.
Exactly.
Right.
Yeah.
Right. So that's kind of what's going to be driving and going to be behind a lot of our conversation today. So let's get into the conversation a bit around. I raised at the beginning, the topic is about profit optimization. Okay. So let's start with the easy bit, profit optimization, the goal. Come on, answer this one for me, because I never found it out completely. I was losing loads of money at Eurostar. Come on, what's the secret to profit?
Well, I mean, the profit equation is really simple, right? Profit is simply equal to revenue minus the cost, right? So really, the secret is that you really need to do both. You need to have a good estimate of the cost, and you also have to have ability to optimize the revenue, right? So you have to have both terms of this equation in order to optimize your profit.
Okay, so optimize revenue on the one hand, estimate cost, as you said, on the other side. But I'm assuming though that the cost half, I'm assuming is the most straightforward of those. I mean, if you look at business to business, where a lot of our listeners are, cost was very predictable for many years, wasn't it? It's what your material costs are. The global supply chain means you can assume almost an infinite supply, and given that, therefore, that most businesses know their material cost, you can get there quite straightforward. Do we really need to estimate it?
Yeah, well, I would say that like in some industry you can use this material cost, but I would say the material cost it's not always the best estimate of this cost, and yeah, and then the main reason is because I would say when you talk about material cost, you usually mean like the cost of production, right? I mean, so whatever it costs, including the material, labor, whatever goes into it, right? So and the thing is that like there's a lot of, I would say, product and services that are not directly linked to production, and these are, for example, in, I would say, industries such as travel, transport and logistics, energies and utility, right? But basically, I think any product and services where the supply is somewhat limited, like such as hotel, airline, cargo, shipping, railway. So all these are examples where it's how do you price a seat in the airline, right? I mean, so you mentioned that putting beds in the flight before, right? So how what's the cost of that bed, right? On the flight, I mean, it's not the cost of what it costs to make that bed, right? It's really the cost, a better estimate of that cost, it's one that what the market would pay for. It's essentially an opportunity cost for that bet, right? Because you have a limited amount of bet. If you actually sell that right now, you couldn't sell it later because you only have fixed amount of them, right? So based on your estimate is what the future kind of demand is for that bet, right? You can actually get at what we call the opportunity cost, right? And so that's actually typically, I think, a much better estimate of the cost of a lot of this product. And the reason this is important is because this cost estimate is used to kind of I would say as a safe kind of guard, right, to prevent you from selling below that cost, right? Because when you sell something below that cost, you are essentially losing money, right? So it's you want to make sure they have an accurate estimate of that to make sure that you don't redline, go below that red line.
So this opportunity cost way of sort of working out your pricing or what you're doing is assuming. I presume that explains why, for example, an airline seat might be at a different price depending on how far away you are from the flight. They'll adapt the price accordingly based on opportunity cost, rather than just charging everybody the same price for the same seat.
Exactly.
Right.
Yeah, I mean, so you have to, and how you estimate that depends on the demand of the market.
Yeah.
Right. So essentially, this opportunity cost it's a cost that's kind of based on the market demand rather than the cost of the material. That's kind of already fixed. Right. That's kind of
So you're working out. So I get this because you're understanding your demand curve, but at the same time you've got a supply that's going to suddenly come to an abrupt halt when that airplane takes off, or when that day has gone past for a hotel or whatever it's going to be. Got you. Okay, understand that why it's more complicated on the cost side. Let's turn to the revenue side then. Tell me about that side of the profit equation.
Yeah. So for that side, I would say I would say that there's many factors that actually drive revenue. Okay, and certainly sales would drive revenue, and even I would say marketing also drive revenue. But marketing is a kind of further upstream, right, from sales, and so its impact on revenue is actually a little bit less dramatic. Right? And even I would say if you go further upstream, designing a good product also will also help drive revenue too, right? But that's even further upstream, right? So it's kind of impact on revenue is even less significant, right?
You realize you've just destroyed my entire career there, Michael, who built his career on marketing and product development. Thanks a lot, mate.
Well, I mean, they do help, so but I would just say that,
I take your
the
point.
most direct lever to drive revenue is pricing.
Yes.
Okay? Because, if you consider pricing, right, I mean, that's even kind of, I would say, even the sales is actually further upstream from pricing, because you have to have a price before you can sell anything, right? So pricing has probably the most direct impact on revenue. So the best way to optimize revenue is essentially to optimize price. Essentially, you want to find the best price, that maximizes your revenue. Yeah.
So, I mean, historically, I understand that. And historically, therefore, you'd break down the market into different segments. You'd work out who was, most likely to pay what. And then segmentation would very much drive your kind of pricing models. Is that still the case?
I would say that, traditionally, that's what people have been using.
Yeah.
And it's a very popular method, and people understand it. But it's not, I would say, it's not working well anymore. So, yeah. And the reason is, there's several reasons for that. I mean, so one is certainly that the market has become a lot more volatile, right? As you said before, right?
Yeah.
The supply chain is being disrupted, it's being restructured, and we no longer have infinite supply, right? In fact, we constantly experience, product, going out of stock, if you shop in groceries and stuff like that. So even I would say material costs and even shipping costs has become a lot more volatile. So that market is become a lot more volatile. And
is
second,
that driven? That's particularly post-COVID, is it? That is you're talking there, right? Yeah. Okay.
Yeah, I mean, post-COVID, obviously, definitely, I think that certainly the supply chain disruption is caused by COVID, and certainly, and also more recently by, the war that's going on, right?
Yeah.
So lots of disruption we see today, right?
Yeah.
So what that means is that if you do this pricing by segmentation, which is a static kind of segment structure, right, which you don't update very frequently, it's not going to be able to capture the dynamic, the volatility in the market, right? And the other thing that changed is that product typically become much more complex today. Before you may just say I want a light bulb, for example, right? And today you say, oh, you may have LED bulb, you may have a color changing bulb, you may have a light bulb that's powered by solar power. You may even be able to control this light bulb with Wi-Fi or with your phone. So there's lots of feature, because the product has become a lot more complex. And also, besides the product being more complex, I would say that the business environment in which you transact is also become more complex as well, right? Before you may think that it's a large company that's buying this in the U.S. that's buying these light bulb. Now you may actually have very detailed information that okay, this is actually a hospital in Southern California employing 2,000 people with $1 billion revenue that's buying this light bulb, and even you have details on how this transaction is being made. For example, he's actually buying online. He actually wanted expedited shipping, and it's actually during the summertime, and actually the competitor is actually offering 10% discount right now. So all these are, I would say, business and kind of contextual information that makes this.
So basically, as I understand it, and you're saying, so what that means is, whereas in the past I would have grouped segments based on a broad set of characteristics, and I would have had maybe 4 or 5 segments that I was aiming at. You're effectively getting down to almost like a segment of one. You're saying you've actually got the data out there to tell you about every individual customer if you wanted it to.
Exactly, right. So if you have so many different attributes, right, basically, and you try to segment them, you basically divide your data so thin that basically each segment probably only have a handful, right, of transaction in there, and that's typically not enough to give you a good estimate of what the willingness to pay of the customer is, right? So that's one of the problems. And today we actually, as you said in the beginning, right, we have access to all these very detailed attributes, right? So and that creates lots of problem for this traditional segmentation approach. I can imagine. And I think there's many challenges, and I'll just highlight kind of maybe 4.
Yeah, please. Take us through a few of them.
Yeah. So first, because in segmentation, what you do is that you pre-segment. Before you do any analysis, you divide the data up into different segments. Right. So all the transactions are divided into these micro segments that have very similar willingness to pay. Right. So even one of the problems is that you have no kind of what we call this cross segment knowledge sharing. Okay. So there may be 2 segments, right? Even though the attributes is very different, right? But they may still have very similar willingness to pay. Right. They may still kind of but if you actually segment them into micro segment, before you even do any analysis, right? There's no kind of knowledge sharing between those segments, right? So and it also doesn't support continuous attribute. For example, things that are continuous, like for example revenue, annual spend, and all this are. So you always have to kind of bucket them, right? So this is a company spending $1 billion to $5 billion, and then so you have to put them into buckets, right? And then so that's not a very accurate kind of, I would say, estimate. And the more bucket you have, right, that the data become more sparse, right? So you can't have too many, right? So if you have a few, then it's very coarse. It's not very accurate. So it's fighting, kind of juggling, this on 2 ends, right? So it's hard to find a good balance there. Right?
I remember actually one of my colleagues once at Procter & Gamble trying to sell a plan through to his management based on a segment of 3 people. It didn't wash with the senior management team. Has been statistically significant, I have to say.
Yeah, three is not good enough there. So. Yeah, and so I think the third kind of, I would say, challenge with segmentation is that typically they're the price recommendation, right? So you come up with a segment and you come up with the recommended price. So typically the recommended price is kind of rules driven, right? Typically what company do is that they will segment all the transactions into microsegments, and then within each microsegment they will take the mean, the average of all, because these are all transactions with similar willingness to pay, right? So they take the average within that segment and use that as a kind of as a guide, right? And they may have kind of heuristics and rules, right? For example, if you pay above the mean already, then since you're already paying above the mean, then we just let you continue to pay above the mean, right? If you are below the mean, then I want to recommend you pay higher, toward the mean, so it brings the segment kind of wants to pay up, right? So these are kind of heuristics. We know it will help, but is that the optimal? There's no guarantee that it's optimal, right? There's no guarantee that that will give you the, because if you let these people who pay above the mean continue to pay above the mean, right? Maybe you could risk losing them as a customer, right? So there's no kind of optimality in these kind of heuristic, right? And mainly the reason is because there's no trade-off information for price deviation. And the biggest problem with segmentation is obviously this data sparsity problem, right? And like I said before, the more attribute you have, the more detailed data that you have about this transaction, this customer, this product, and the more kind of sparse your data can get, so it's actually makes the problem worse.
Got you. Okay. Well, look, you've done a great job of outlining the challenges. On the cost side, we talk about the need to look more kind of opportunity costs rather than the material costs, because it's more difficult to measure anyway. In the area of revenue side of things, you've talked about some of the challenges there. The market becoming more volatile, products are more complex, the business environment itself is more complex. And that leads into some of the issues that you've described with the traditional approaches like segmentation, because no cross-segment knowledge sharing doesn't support continuous attributes, etc. So it looks to me like the scene is set for you to put on your superhero cape now and tell us why AI and neural networks and everything else is going to solve all our problems for us. So come on, give us the solution, Michael.
Sure. Well, I mean, so the trick really is to get rid of segmentation completely. Right? I mean, all these problems, all these challenges were created because you a priori segment the data into microsegments, right? So we just don't do that, right? Don't segment at all, right? So now the advantage of having so much, I would say, data and so much detailed attributes on the customer, on the product, on the transaction, is that you can actually just use those data as predictors and feed them into a neural network that you train to predict people's each one of the customers' willingness to pay directly. Okay, so you basically are turning the segmentation problem into a prediction problem. Okay, so you take all the product attribute, all the customer attribute, and all the transaction attribute as input. Okay, and you feed them into this neural network, and that will give you outputs of that neural network is essentially the price that people are willing to pay, right? Based on all those attributes, right? The input that tells you what those customer, what the product is, and what the transactions are, and what their willingness to pay should be. Okay, so. Yeah, so now because you are kind of using the entire data set, right? There's no more data sparsity problem, right? And now because you're using all the data all at once, right, all together, now transactions with very different kind of attributes that are normally segmented into different segments. Now they can share knowledge, right? I mean, maybe this hospital had never bought a kind of color changing light. Maybe you don't need, but there are actually a lots of, I would say, customers in California, right, who has bought color changing light, and you can actually share those knowledge, right? And so you could there's a lot more, I would say, this knowledge sharing, and obviously, the neural network can certainly take in continuous attribute, right? It doesn't really, it's just an input to the neural network. It doesn't really matter whether it's continuous, categorical, or discrete. So using this neural network to kind of predict willingness to pay, automatically address 3 of the 4 major problems with segmentation, right? So, and what's even better, with neural network is that you can even input additional data elements if you have, okay? So if you have some proprietary data element that you feel can help you predict, people's willingness to pay better, you can actually just provide them, and the neural network will actually make use of them if it's useful, right? If it's not useful, you would just set the weight to 0, okay, from the learning process, from the training process, and not use them. If actually useful, then you will, have a weight that's significant, right? So.
Right. So this kind of magic from the neural networks has then given us the willingness to pay, as you describe it. So does that mean then we just take that then, and that's now the price we're going to offer to customers, is it?
Oh no, that's not okay. So predicting the willingness to pay is just the first step, right? So this only tells you, like, for this customer buying this product under these kind of transaction condition, like what was the price that historically customer willing to pay, right? It doesn't tell you whether it's a good price or bad price to offer. It just tells you that's what people are willing to pay before, right? That's why it's called willingness to pay, the willingness to pay price prediction. Okay, that's only the first step, right? And to actually offer, a price, or you come up with the offer price, you need the optimization step, the second step. Okay, so the second step is what we call this win rate optimization. You have to essentially pick these same historical data and essentially look at them from a different kind of perspective in terms of the win-loss information, okay? So which one of these transactions was won and which one of those are lost, right? Essentially come up with essentially a win rate curve, essentially, okay? So obviously the one with lower price, you're gonna win a lot more frequently. The one with higher price is gonna win less frequently and maybe even lost some of them, right? So if you have that, win rate curve, right, which essentially tells you the probability of winning this deal at different prices, okay? Now from this, you can actually get the expected revenue or margin, which you have the cost, right? Because remember, we have the cost estimated, right, from when we actually talk about estimating opportunity cost, right? So when you have this win rate and you have the cost, you get expected revenue or expected margin. And you simply multiply the price by this win rate, right? So if your win rate is say 100% and your price is whatever it is, it's just the revenue is that is just that whatever the price is, right? So so now you can actually come up with essentially this expected kind of revenue, expected margin curve. Essentially it's a curve, right? Based on different price, you're gonna win some, you're gonna lose some, and you're gonna actually have different lows of margin at different price, right? So now since you have a curve, you can actually optimize it and find where you actually hit the maximum is, right? And what that price was, okay? So that's how you get that the price, find the price that maximizes your margin, right? Now this actually will address the final challenge of segmentation, because remember I said before that the price from the segmentation approach is recommended based on heuristic, right? I want to bring these low performers who pay below the mean. I want to recommend toward something higher, toward the mean, to bring them up, right? But there's no guarantee for optimality. But because now you have this margin curve, right? You actually have what the true optimal is. You know exactly what price you will give you the optimal, right? The optimal margin or optimal revenue, right? So the price recommendation is based on optimization, no longer based on rules and heuristics anymore. So
good. Listen, I'm going to ask you in a minute or two about the extent to which we trust these sorts of things, because it's this black box of doing stuff. But before I get to that question, I noticed a couple of comments that have come up on the tab, which I just thought I'd share with you. And just sort of, so Mark Gillam has asked a question. He says, Does AI stroke machine learning undertake sample testing to check its understanding and then optimize? For example, let's assume the calculated $10 is the optimal price. Does it ever try $11 just to see what happens?
Yeah, so we do have some these what we call price exploration, and that's what we call we actually do that for some of our airlines, like ancillary pricing, because ancillary pricing historically don't have a lot of price variability, right? For example, the price for bringing an extra bag is $50, then it's always be $50, right? So if you train the machine learning algorithm to predict what they want us to pay it's going to be $50, right? Because that's what all the historical data said it would be, right? So if there's no price variability, then that's where this price exploration it becomes really extremely important, because you don't know if that's optimal, right? Because historically it's always been 50, right? And people, so you don't know what people's willingness to pay is when you actually deviate from 50. So you want to systematically explore that, and that's done with what we call reinforcement learning, right? You basically charge at essentially a price around this $50 to explore to see whether there's more people buying or less people buying and so on, and based on and how does it actually impact your revenue. At the end of the day, right, you may have more people buying, right, if you actually charge lower, but you may actually lose revenue, right, because you're charging lower price now, right? So what the true optimal is, really depends on this essentially, you're both sides of that equation, right? That revenue and the cost, right? So you have to actually get both, and this can be done definitely. AI can definitely do that, do this price exploration. Yeah.
Excellent. I mean, there's a couple of other questions, a couple of which I'm going to save till nearer the end because they're more kind of general about sort of ethical considerations and things like that. But sure. I wanted to ask one question that Julia Jews put through a question that says, relating back to what we discussed before we came on about business to business, B2B. She said, does this work for B2B as well, particularly where you would normally have one-to-one price negotiations and pricing tends to be specific account related? Does this technique still work for that?
Yeah, in fact, this is actually very good for price negotiation. This is actually, now because you remember, I have this kind of revenue or margin curve, right? So you can actually optimize it and find what the optimal is, right? But you can also find, I would say, a range, right? Say I want to find not the optimal, but say 99% to optimal, right? Then you can actually you have that curve is a kind of a concave down curve, right? So you would know that you will have kind of give you an envelope, right? So you can actually charge the floor price and the kind of the ceiling expert price, right? That give you a range, so you can actually negotiate, around it, right? So you don't have to say, all right, I'll offer this, take it or leave it, right? I'll actually give you a range, so your salespeople are confident that within this range, my win rate is so and so, right? Because you can see that. So now you have all the information. You have the win rate. You have that if you actually charge at not the optimal, what are you sacrificing in terms of win rate? If you charge over the optimal, right, price, what are you sacrificing there, in terms of the win rate as well? So because you have this, the trade-off when you deviate from the recommended price, this optimal price, right? You can actually make those trade-offs, yourself as well.
So you're basically sending your key account team, your sales team in armed with a much better understanding of what the customer's likely to be thinking about when you go into an individual, account negotiation, exactly. I guess. Gotcha.
Exactly.
Okay, I'm going to come back to the other questions, towards the end. But one thing that interests me about this is, look, neural networks, AI, beyond the comprehension of mere mortals like me, it's a magic black box, this neural network thing, and it comes out with an answer, which is great, and it's great to have an answer, but how do I trust it? How do I know it's doing the right thing for my business? Because I don't know how it got to that answer. It's just given me an answer. And in most businesses, again, if you don't really understand it, you're not necessarily going to adopt it. So, because, at the end of the day, you've got a nice thing you're trying to sell me, but it's my career that's on the line if the business doesn't work. So how can you help me, trust this as a way of putting my business into the hands of this neural network?
Yeah, I think I hear you. That's actually, one of the major, I would say, trust and adoption is one of the major roadblock for a lot of, I would say, enterprise. in adopting and realizing the true potential of AI. And we take that very seriously. We basically, making sure that, if you actually do use a neural network, it's great. It solves a lot of problems. Like, as I said before, right, addresses 3 of the major problems of segmentation, right? And then using the win rate optimization, we address the last problem, the major problem that we talked about. But the fact that you're using a neural network means that there's a black box in there that you don't understand. You can't really interpret what it's actually doing, right? So now, the black box nature of this neural network is actually, I would say, a little bit of a misnomer, okay? Right. Because I would say that, it's really just a complexity. It's just that it's not that you cannot understand it. It's so complex that we can't describe it in English or something like that, right? So we actually, what we do is that we use what we call explainable AI. These are methods that essentially try to explain what's going on in the black box. There are other algorithms, right, that we actually apply. Okay. Right. Once the model, this neural network model, is trained, right, all the weights and all the layer structure are kind of fixed, right? We can actually apply these tools, such as explainable AI, to actually explain what this network might be doing. Okay. So one of these is, for example, called Shapley value. Okay. And basically, it allows you to visualize and understand the contribution to the final recommended price. What's the contribution of each one of those attributes that you put in, right? Remember, you have lots and lots of attributes around the product, around the customer, and around the transaction. For example, if you have, whether your light bulb is color changing or Wi-Fi control or solar power, or all that, right? So how much does each one of those features contribute to the final price, right? So if these features are maybe highly demanded, people actually like those features, then each one of those probably will increase the price a little bit, right? But maybe solar power, we increase it, by $1. Maybe the fact that it's color changing, we increase it by $2 because people like color changing bulbs a lot more, right? So, but then you also have other transactions on, other attributes on the customer, right? This is a hospital, right? It's employing 2,000 people. It's $1 billion revenue, right? So each one of those also contribute something, right, to the final recommended price, right? So the fact that it's a hospital, right? If you don't know that it's a hospital before, you say, oh, it's $1 billion revenue company. It's probably a big company. Oh, it's a big bucket, right? So I would probably charge them higher. But the fact that that it's a hospital, $1 billion revenue for a hospital is actually not very. I would say in a hospital probably make more than that, I would say, right? So you're probably not doing well. Maybe you want to reduce the price a little bit for this hospital, right? But then you also have, the attributes on the transaction, right? The fact that, they want to expedite shipping, right? They bought online, right? You could probably lower the price a little bit if they bought online. But the fact that you actually, want to expedite shipping probably means that, he needed this urgently, right? And then that means you could probably increase the price a little bit because they probably have higher ones to pay, right? So all these are, I would say, detailed kind of contribution of each one of those attributes. Can actually give you a dollar amount, how they actually lead to the final price that's recommended, right?
I find that's really interesting. So I remember, I say, if I go back to my consumer goods days at P&G, one of the things I love to do is you build a regression model of your product, dishwashing liquid or whatever it was. And there'd be a number of variables you build in that you'd understand the impact of each of them: advertising spend, how many stores you distributed in, competitive activity, product quality, etc. This sounds like a kind of 21st century version of what I was doing on Excel spreadsheets. This gives you a much more detailed understanding of the contributions of every different element that's going to actually determine the final price that you're going to be able to recommend.
Yeah, exactly. So with the linear regression model, right? So the contribution is essentially those weights, right? Yes. The weights that you get on each one of those terms, the attributes are essentially the contribution, right? But with the neural network, this is a very complex model with nonlinear, with many layers, right? So that contribution is actually much harder to it's not actually explicit. It's not actually the weight of each one of those the nodes, right? It's actually much more complicated. It's the nodes get feed into every other node, so there's many layers. So the way you calculate that contribution is not so straightforward. It's by this method called Shapley value, and that's how it's calculated. Yeah.
But I was just thinking back to my days at university when when you were taught regression modeling in the early days, you had to build a regression model by hand and do all the columns and work it all through so you understood how it worked. I can't imagine trying to do something like that with a neural network somehow.
It's probably not going to work. I wouldn't even be able to do it by hand. I have to code it up in the machine, in my Python, and let the machine punch out the number. So Shapley value is just, I would say, one of these explainable AI methodology that we employ, right? And obviously, I think people are familiar with segmentation, right? One of the benefit of segmentation is that you get a comparable transaction. You get other kind of transaction within that segment that you could have a reference to. You could kind of say, does it make sense, right? This transaction, does it actually look like these other ones that's in the segment, right? And what these other ones, what their willingness to pay was, previously. Does this one kind of match somehow the rest of this in the segment, right? So since we have no segment now, we give it a segment completely, right? So how do you come up with that comparable transaction, right? Yeah. But so the way we deal with this problem is that we simply find other transactions that's similar to the one in question. Right? So, and that's done with what we call a k-nearest neighbor algorithm, just using essentially some kind of weighted Euclidean distance, right, to calculate how other transaction that's actually close to this one in question, right? And because we have the essentially the contribution for each one of those attributes, right, from which we calculated from the Shapley value, we can actually use those to weight these different attributes, right, to calculate when we actually calculate this similarity, right? If, for example, like we used to think that geography is really important, but according to this Shapley value, maybe it doesn't actually contribute very much, but then you should not care about that much. So,
listen, unfortunately, we're running quite short on time here. We can probably do another 5 or 6 minutes here. So I just wanted to get through a couple of other things if we could quite quickly, just to make sure we get the full picture before we finish. This approach, I mean, it's quite radical, getting rid of segmentation and doing it in another way. Just out of interest, just a quick answer if you could. What was the inspiration behind this? What led you down this road?
Yeah, and that's actually quite interesting because this approach is actually inspired by our airline customers, because airlines have always been dealing with, I would say, a limited supply of seats, right? Their supply of their goods, right, their service, essentially this seat, right? It's always limited. The airline call them capacity, but capacity of airline is essentially the supply of their seats, right? Yeah. So what they have to do is they have to forecast the future demand and match to the remaining capacity that they have, right? And that matching the supply and demand is what in economics, we know that's the equilibrium, right? And that gives us the optimal kind of revenue, right? So what they do is that they use this forecast and optimization approach. They forecast first the future demand and then optimize it. And we actually doing something very similar, and this is actually inspired by that.
Fascinating. Yes, I remember the capacity management models well from my airline days. Come on, then, the $50 million question. Does it work? Can you give me some examples of where it's actually made a difference to somebody?
Of course it works. Yeah. So we actually did a few study. We call it the preview program. For customers to preview how this algorithm actually worked, right? And we did it with the U.S. Food manufacturer, okay? And that first step in the willingness to pay price prediction piece, we actually get a 22% improvement. The RMSE error, or the root mean square error, actually reduced by 22%. Okay, wow. And how that translates to revenue is that, it actually drove a 4.5% attainable revenue lift. And we actually did this for another customer, as a European based global kind of industrial manufacturer. And they also realized about 20%. It's actually 24% root mean square error reduction in terms of the price prediction. And how that translates to business outcome is they get 11% margin improvement, right? So they actually use these two studies actually use two different kind of objective. One use kind of attainable revenue, the other one use attainable margin. So, but they both are very significant. Yeah.
Very good, very good. Right now, I'm aware of just the time at the moment. Now, I think there's a study I know that you guys did with Forrester, a Forrester report on the benefit of adopting this, and I believe I'm just checking on the chat here, but I believe there's a link there for anybody who wants to download the Forrester report, which will give you a lot more the detail on the things that Michael has been talking about, and also a bit more on the results and showing where it really has worked in the past. But I didn't want to let everybody go, and I think I'll get slapped on the wrist for overrunning by a couple of minutes, but I didn't want to just lose out on the two other questions. So again, we're into brief answers, I'm afraid, Michael, on these ones, but
okay,
there's been a couple of other questions that have just come up on the thing that I just wanted to double check. Uwe asks, what ethical considerations should businesses keep in mind when using AI for profit optimization? And then the second question is from Michael, who says, as businesses increasingly rely on AI for profit optimization, what potential risks or downsides should we be aware of, and what can we do to mitigate those risks? So quickly on ethical considerations, and then downsides and how we mitigate that risk.
Yeah, so one of the most important ethical considerations is obviously you don't want to make this pricing discriminatory, right? You don't want to price, and so you want to make sure that these this neural network algorithm, right? It doesn't take in like any attribute that's related to personal kind of identifiable information, no PII, and certainly you don't want to use any kind of protected characteristics such as race, gender, and all that, right? So those information are definitely, you should just remove them, right? If you have them, you should just remove them and not allow the neural network to take them, right? And even more as a cautious, right? You should actually make sure that nothing is actually heavily correlated to those, right? Because there's a very famous example where people, they remove all the these protected characteristics, but then they actually use zip code, and zip code is actually highly correlated to people's kind of population that actually live in that there, right? So that's actually they should probably remove that. They actually subsequently did found out, and they actually removed that afterward, right? So those are things that you should be careful when using AI to do profit optimization.
You can absolutely screen out that kind of personal information. Yeah, got it.
Yes, for sure. So so the risk, right? I mean, I think right now, as with any technology, right? I think there's a huge, I would say, this first mover advantage, right? I mean, so if you're the first mover in your industry, right? Good for you, right? The downside, of course, is that if you're not the first mover, right? Then you're at risk. You need to, just hurry up and adopt this, right? Otherwise, the risk is that you get left behind, right? You become not competitive. So
it's it's an interesting one, actually. I mean, because I know that the first mover advantage is a very important one too, because I know there were some other examples that you have of where people have got success that you can't even tell us who they were, because they're so keen on keeping that first mover advantage and not letting us know who they were.
Well, I mean, this is sometimes called the CFO's best kept secret to profitable growth, right? This is for a reason, because these technology drive profit so much that nobody actually wants to talk about it, because they don't want their competitor to know about this secret weapon.
Well, listen, I mean, looking at where you said the origins were, I do remember from my British Airways days, I mean, the British Airways capacity management model that they used, their revenue management model, was absolutely top secret for many years. And it was the absolute secret to BA's profitability back in the kind of 1980s, 1990s. For exactly that reason, as you say, they didn't want to share it with anybody because it was the key. Listen, unfortunately, we have run out of time, and we are going to have to close in a second or two. I just want to make a couple of thank yous, first of all. The first one is a big thank you to you, Michael, for joining us. This is Michael Wu from Pros. And, honestly, in 48 minutes or whatever we run at so far, you've taken a hugely complex area and provided with an explanation that even I could understand. So that really is taking that deserves tremendous accolades. No, seriously, well done. I think it's been very, very interesting to learn more about it. So thank you to you. Thank you, of course, to Pros for making this happen. And as said on the chat, if anybody wants to find out anything more about this, there's the Forrester report is available. There is the link there. Pros, P-R-O-S, is they're mentioned in the report as well. I'm sure we'll be delighted to talk to you if you want to find out a little bit more about how it might or might not be relevant to your own businesses. And my last thank you is to you, the listeners. Thank you so much for listening in. I hope you found it as fascinating as I did. And we'll look forward to seeing you on a future discussion. But for the moment, reluctantly, as always, because we could have gone on for a lot longer, I have to say, my name is Hamish Taylor. Thank you for joining us, and we'll see you again at a future discussion. But for now, goodbye.